Welcome back to another episode of Tutorials with Ike. Today we are going to be doing another topic and the introduction to business finance, and the topic is called time value of money. If you are new to this channel, don't forget to hit the like button, subscribe, comment, and share. And if you are new to this channel, make sure you subscribe so that anytime I upload any tutorial on any course, you'll be the first person to see it so that you stay updated. Now let's get straight into today's topic, time value of money. So basically, time value of money talks about how time can change money. That's basically it in simple terms. So you guys know that one city today is not the same as one city yesterday. Neither is it the same as one city tomorrow. You get it? Gone are the days where water was 10 pesos. So it means if I had one city at that time, I could buy 10 sachets of water with just one city. Later on, it changed from 10 pesos to 20 pesos. I have that same one city. The one city has not changed, but then it has now changed to 20 pesos. So now I can buy 5 instead of the 10. And now a sachet of water is 50 pesos. So it means with that same one city, I can buy just 2 now. So it just shows you how time has changed the value of money. So that's basically about time value of money. It shows how time can change the value of money. And when it comes to time value of money, there are two things we talk about, two main things we talk about: the future value and the present value. The future value and the present value. Now let's talk about both of them. So future value is, in basic terms, how much your money is going to be worth in some years' time or in some months or some days' time, basically. So it's like predicting how much your money will be worth. So assuming in 2018, water was 20 pesos. So if I wanted to predict, I can predict that, oh, maybe right now water will be like 50 pesos. That's about future value. You want to see, so right now that's water is 50 pesos. I can predict that, oh, maybe in 10 years' time, water will be maybe 1 cedi or 1 cedi 50%, depending on how I do my calculations. So that's about future value. So future value just talks about how much your money is going to be depending on the investments you make. So if you're going to make an investment at any bank or any institution, obviously, assuming you invest 1,000 cedis into the bank, it should be more. So future value helps you calculate how much you are going to get at the end of the time you invest it. So if I invest 1,000 cedis at EcoBank or Access Bank or Unibank or anywhere, it is future value that I'll use to calculate how much my money will be worth at the end of the time I want to invest. If I want to invest in Access Bank for 5 years and I'm investing 1,000 cedis, I'll use the future value formula to calculate how much I'll get at the end of the 5 years. So it's actually helps so that you see whether it's like a good investment or not. That's basically it. And the formula for future value is here. So future value. So this is for one time. That's a one time. So one time means that you are paying just once. So right now I can decide that, oh, I have 1,000 cedis. I don't know what I'm using it for. It's just there. It's just lying there. I want to invest it since I'm not using it. So that's the one time. So I've just paid the 1,000 cedis. That's all. Some people pay like every year 1,000 cedis. It's like susu. But then this one is just once. So maybe I have 10,000 cedis here. I just want to invest it. That's just once. So if you're investing once, you use this formula. The formula is PV times into bracket 1 plus R, or in brackets then exponent n, or to the power n. Now let's break down this formula. The PV you see here is the present value. The PV is the present value. Now what is the present value? The present value is the value you are going to deposit at the current time. So right now, if I'm going to EcoBank to deposit any amount of money, let's assume I'm depositing 1,000 cedis, then my PV now becomes 1,000 cedis. Are you getting it? If I'm depositing 5,000 cedis, my PV becomes 5,000 cedis. So PV is basically how much you are going to deposit, your present value now. That's PV. Then the one is constant. Then R is the rate, more like the interest rate. So obviously the bank is going to give you an interest rate. It can be 18%, it can be 19%. And when you're in time value of money, anytime they give you the rate, let's say it's 18%, you always divide it by 100. So if you are given, let's say, your rate to be 18%, it's going to be 18%, then it's equal to 18 over 100. This is what you're going to get. Then you move it 2 zeros. So you're going to get 0.18. So you always, anytime they give you the rate and it's in percentage, you always divide it by 100. So you are going to work with the 0.18, not the 18%. When we solve examples, you get what I'm saying. So yes, so the R here is the rate, And the N year is the number of years you are going to invest. So if I have 1,000 cedis, I can decide that if I'm not using it, I can even decide to invest it for 10 years. I can decide to invest it for 20 years, for 30 years. So if I'm investing it for 10 years, my N becomes 10. If I'm investing it for 5 years, my N becomes 5. If I'm investing it for 2 years, my N becomes 2. That's basically it. I'm going to take it again. The PV is the present value. So if I'm going to deposit an amount of money, let's say 200 cedis, my PV will be 200. The one is constant. So whether you are dealing with cedis, dollars, or anything, you maintain the one. Then the R is the rate. And I said that anytime they give you a rate, let's assume they give you 50%. You don't work with 50%. You work with 50 over 100. So anything they give you, once it's in percentage, you know percentage is over 100. If you score 70% in exams, it means 70 over 100. So you're going to do 70 over 100. Then you do your workings and use that one to work as your rate. Then the N is the number of years, or the time you are going to invest it. That's basically it. So now let's solve some questions under future value for you to understand. And like I said, this is one time. So let's solve a question. Now, the first question: if you invest thousands this at an interest rate of 10% per year, what will be the value in 3 years? So let me write the question. If you invest 1,000 cedis at an interest rate of 10% per year, at an interest rate of 10% per year, what will be the worth in 3 years? What will be the worth in 3 years? I hope you guys have your books and your pens, because in this topic you need a lot of calculations. So I want you guys to solve it. Pause the video and solve it before I actually solve it. Yes, so let's get straight into it. So the question is, say if you invest 1,000 cedis, let's say at EcoBank, at an interest rate of 10% per year, what will be the worth in 3 years? So they said 1,000 cedis. They didn't say per year or anything. So meaning this one is just once, 1,000 cedis. That's all. Not every year you are paying 1,000 cedis. If you invest 1,000 cedis at an interest rate of 10% per year, what will be the worth in 3 years? So right now, let's go back to the formula and identify, yes, the things in the formula. So PV, like I said, is the present value. So the present value is how much I am investing. And here it is 1,000 cedis. So I can say from the formula it's equal to PV times. So my PV is now 100,000, sorry. My PV is now 1,000, which is my present value. Then times into brackets. The one is constant, so no matter how much you are dealing with, you maintain the one. Then plus R. R is the rate. And I told you earlier on that when you are given the rate, you always divide it by 100. So 10%, you're going to divide 10% by 100. So you're going to divide, so it's going to be 10 over 100. Then you move a 1, 2, 1, 2. Then you get 0.1. So it means now the rate is actually 0.1. That's what you're going to work with every time. You divide it by 100. So 0.1. So 1 plus 0.1, which is our 0.1. Then N. N is the number of years. The number of years. Now they said what will be the worth in 3 years. So the number of years is 3. That's all. Now you solve it and you get your answer. Let me get my calculator then. So I have my calculator now. So let's solve it. 1,000 times into brackets 1 plus 0.1 and close brackets or exponent 3. So when you punch this on the calculator, you can just punch everything on the calculator. You can also do it step by step if you are not very familiar with the calculator. So here I got 1,331. So this is the final answer. So the question said, what will be the worth in 3 years? So it means now it is 1,000 cities, but in 3 years, it is going to be 1,331. So I mean, I'm getting 331 extra. That is more like my interest. So that's what the question is all about. I hope you guys get it. Later on, we'll solve more questions on it. But then let me know in the comment section if you don't understand anything we are doing so far. So that's basically for the future value when it comes to one time. Now I'm going to go to the next one. Now let's go to the next one. The next one is the future value ordinary annuity. Now let me break that down. Now the first one, we said it is one time. So that one I have 1,000 cedis. I'm not doing anything. Like I'm not using it for anything. So I just invest the 1,000 cedis. That's all. But this one, the FVN or a future value ordinary annuity. It's just like the first one. The only difference is that for that particular one, it is reoccurring, meaning you pay every year. So this one, perhaps I have a very decent job. I know that, oh, every year, the 1,000 cedi year, I have it. So I just want to invest it so that later on I go and take it. So unlike the first one where I just had 1,000 cedis, I went to give it out. That's all. The next year I don't invest in it. The next year I don't invest in it. I just go and take my money at the end of the 3 years. This one, every single year I am investing. Every single year I'm investing. So maybe this year, December, 1,000 cedis. When I'm done working, my profit 1,000 cedis. I go and put it down. I go and invest it. The next year, December, 1,000 cedis. The next year, 1,000 cedis. So when they say you should calculate for something, let's say calculate the amount of money if it's paying every year or every 2 years, then that one you use the future value ordinary annuity. I hope you guys are getting it. So once again, the difference between the first one and the second one is that the second one you pay every year, but this one is just one time. That's the difference. Now let's solve a question under it. Now, yes, I'm going to put a question on the screen so that you guys see it, so that I wouldn't need to write it again since it's taking time. So the question is, if you save 500 cedis at the end of each year for 4 years at an interest rate of 8%, what will your savings be worth at the end of the year? I'm taking the question again. If you save 500 cedis at the end of each year for 4 years at an interest rate of 8%, what will your savings be worth at the end of the 4th year? So it's like, imagine like I come to university, let's say level 100. At the end of the year, I know that I'll get 500 cedis. Maybe the savings my parents give to me, so 500 cedis. So every December, 500 cedis, level 100, December 500 cedis, level 200, December 500 cedis, level 300, December 500 cedis, level 400, December 500 cedis. So every year, and the interest rate is 8%. What will my savings be worth? That's basically what the question is asking. And like I said, this one you are saving every year. So this one 500, 500. It's not like I saved once. So once you see that it is talking about every year, you are saving every year, you are investing every year. I mean, you are making any sort of payment every year, then you know you are talking about the future value ordinary annuity. Are you guys getting it? So now, yes, let's look at the question now. So now now let's look at what the formula, yes, the formula means. So the formula is P times a fraction with a numerator into brackets 1 plus r, then close the brackets, then exponent n, then everything is subtracting 1 over r. So this one is just the formula. So somehow you have to chew it. So that is the formula. Now the P is the amount you are saving or the amount you are investing in any of them. So the P. So this time they said 500. So our P is going to be 500 because you are saving 500 every year. The question, let me read the question again. If you save 500 cedi at the end of each year, so the P is how much you are saving or how much you are investing. So straight away, I can say P is equal to 500 because the question says if you save 500 cedis at the end of each year for 4 years. Now, let's look at the other thing. The R is the rate. The R is the rate. And they said the rates, they said they are giving us an interest rate of 8%. And what did I see earlier? When they give you the interest rate, you always divide it over 100. So what is 8 over 100? 8 over 100 is giving you 0.08. So now our rate is no more 8%, but 0.08 because we divided it over 100. So our rate is equal to 0.08. It's in the question. Now, what else does the question say? Now let's go back to the formula. Then this thing, everything exponent n. Everything exponent n. So the n is the number of years you are investing. This one is 500, you are saving every year. So if it's level 100, level 200, level 300, level 1, that's 4 years. So the n is going to be 4, which is given in the question. They said for 4 years. So straight away, I can say the n is 4 years. Then what else? So we found P, we found R, we found N. Now we can just substitute it back to the equation. So P is the regular amount. So it is P times. So P is 500. So 500 times then a fraction, then into brackets 1. The 1 is constant. Then the R, what is R? 0.08. It was 8%, but because you divided over 100, so 0.08. Then exponent n. N is the number of years. So they said it's in the question 4 years. Then all over R. R again is 0.08. Then this side, the numerator, minus 1. So you realize that the F into the one time one, we didn't subtract 1. So always remember that the ordinary annuity, you always subtract 1. Just remember that you always subtract 1. And that's just the formula for it. So you just punch this whole thing on the calculator. And if you punch it correctly, you're supposed to get... Yes, if you punch it correctly, you're supposed to get 2253. So the question said, what will your savings be worth at the end of the 4th year? So it means at the end of the 4th year, your savings will be 2,253. 2,253. But imagine you are not getting any interest because it was 500 for 4 years. So it would have been 500, 500, 500, 500, 4 times, which will be 2,000. So it means you are getting an excess profit or your interest is 253. That's basically about it. If you guys have any questions, let me know in the comment section. Let's move on to the next one. So now we are done with the future value. Now we are going to the present value. Now the present value is the opposite of the future value. The present value is the opposite of the future value. So what is the present value? Now the first one, we knew what we have right now. We want to know what we'll get in the future. But this time we know it's like someone promised you money that they'll give you 800 cedis or 1,000 cedis next year, but you want to know how much that money is worth now. You get it? Or someone promised you that they will give you maybe 10,000 cedis in 5 years' time, but you want to know the present value now, how much it is worth. Because, like I said in the beginning, money changes over time. You want to know how much it is worth to see if it is good. Maybe poor, it's looking a lot, but then maybe right now, yes. So you want to know how much that money is worth now. So for that one too, it's similar to the first one. You have the one-time one and the ordinary annuity. So the one-time one too, that one is like the person is saying that they'll give you 1,000 cedis in 3 years' time. So you want to know how much it is worth now. So that one is just once. But for the other one, the person is giving you the money. Let's say the person tells you maybe, oh, from now till 2027, I'll be giving you 1,000 cedis every year. That one, you use the second one because it is reoccurring. So anytime it is reoccurring, we always use the formula for the ordinary annuities. But then this time, for the one time, the person just said they'll give you 1,000 cedis at the end of maybe 4 years or in 4 years' time. So once it is just one payment, you use the one time. So that's the present value. So now the formula for the present value, which is one time, if you want to know how much a particular amount of money would be, let's say 1,000 cedis. Let's say someone tells you that they'll give you 1,000 cedis in 3 years. You want to know how much it is now. The formula is Fn over into brackets 1 plus R close bracket exponent n. Let's break the formula down. Fn is the future value. So the person has told you that they will give you 1,000 cedis in 3 years. So the money they said they will give you in 3 years is now the future value. Because they are not giving you the money now. They said they will give it to you in 3 years. So that becomes the future value now. So if I say I'm promising you 10,000 cedis in 5 years, the money I'm promising you that you are expecting to get at the end of the 5 years or the respective time is the Fn. Then let's go to the denominator, 1 plus R exponent. And you guys already know R is always rates. you always divide by 100 as usual, and n is the time. So if it says in 4 years time, n will be 4. In 8 years time, n will be 8. In 10 years time, n will be 10. That's basically it. Now let's solve a question under it. A friend promised 1,000 cedis in 3 years. So let's assume my friend promised me 1,000 cedis in 3 years. So right now we are in 2024. So in 2027, maybe he said he will give me 1,000 cedis. But I want to know how much it is worth now. So let's look at the question. A friend promised me 1,000 cedis in 3 years, and the interest rate is 10%. How much is that money worth today? So a friend promised me 1,000 cedis in 3 years' time, and the interest rate is 10%. You want to know the value of that money now. Now, how do we solve it? Now, the future value. The future value is how much he has promised me. So that one, you don't even need to do anything. The future value is the amount given. So 1,000. Now, into brackets 1, the 1 is constant. Then R. R is the rate. They give the rate as what? 10%. And I said anytime they give the rate, you divide it by what? 100. So now it becomes 0.1 because 10 over 100 is 0.1. That's basically it. Then exponent n. What did I say n is? N is the number of years. So this time it is 3 years. So n becomes 3. So this one, straight away, just punch it on the calculator. You don't need to do anything. Just punch on the calculator and you get your answer. So that is for the present value for one time. So that's if someone is promising you an amount of money in that current, like the person is just giving you once. That's all. But assuming the person is very loyal to you, or the person is so kind, or he has a lot of money, and he says he wants to be bombing you, he wants to be spreading you, he wants to give you thousands every year till maybe 2030, or for 4 years time, every year 1,000 every year 1,000 every year 1,000 every year 1,000. So assuming maybe next year 2025, he said he'll give you 1,000 2026, he said he'll give you 1,000 2027, he said he'll give you 1,000. You want to know how much the summation of the money will be now. I'm going to take it again. Every year, someone is promising you money till maybe 8 years, till 5 years, but you want to add all and see how much that money will be now. And it will be different from every year because 1,000 cedis next year will be different from 1,000 cedis next 2 years. So you want to see how much the summation of the money will be now. The first one, it was 1,000 cedis for, he was giving it to you like once. So maybe in 4 years' time. But then this time, every single year, he's giving you an amount of money. So you want to see how much, if you add 1,000 cedis next year, 1,000 cedis next 2 years, 1,000 cedis next 3 years, and 1,000 cedis next 4 years, how much will it be now? That is about the present value ordinary annuity. So when you get a question like that, you use the present value ordinary annuity. Now let's take a question on it. You will receive 1,000 cedis at the end of each year for 4 years, and the interest rate is 10%. How much are these payments now? So assuming maybe it is not okay, salary is every month, not a salary. Maybe at a job they just say for doing well, some they'll give you 1,000 cedis at the end of each year. Let's take it like that. Sorry. So yes, you will receive 1,000 cedis at the end of each year for 4 years, and the interest rate is 10%. How much are those payments worth today? So yes, assuming someone is giving you 1,000 cedis at the end of the year for 4 years, you want to see how much that money is worth today. Let's say you just want to see it for some kind of reason. You use the present value ordinary annuity. So for this formula, let's break down the formula. You have P times 1. So the P is very similar to this. The P is the same thing here, the amounts you are receiving. So here they said 1,000 cedis. So straight away, you know your P is 1,000. Then times, then a fraction with a numerator, 1 minus into brackets 1 plus. So the 1 here is constant. Then the R is the rate. The rate given in the question is 10%. So once again, it is 0.1 because 10 over 100. So R 0.1. Then exponent negative n. This time, it is not exponent n. Exponent negative n. So if it is 4 years, it will be exponent negative 4. Please pay attention. If it is 8 years, exponent negative 8, not 8. So this time, no matter the amount of years, just put negative by it when you're squaring it or you're exponenting it. That's all. Then or then divided by R. R is the rate, the one we got here, so 0.1. So from the question, the P, like I said, is the amount that you'll be given at the end of the year, or the amount you are getting, which is the regular payment. And they said you will receive 1,000 cedis at the end of each year. So P is 1,000 cedis because P is for the regular payment. Then times, the times is here. Then a fraction, 1 minus into brackets, another 1 plus R. So what is R? The question said, and the interest rate is 10%. So R is the interest rate. And since I told you that when you have a percentage, you divide it by 100, and 10 over 100 is 0.1. So plus 0.1 plus 0.1. Then exponent negative n. It says at the end of the 4 years. So exponent negative 4, not 4. So exponent negative n. Then over R. The R is 0.1, which is 10 over 100. 0.1. Then you punch it on the calculator, whatever you get. That will be the amount you're going to get at the end of the 4 years. So punch it and you guys let me know what you get in the comment section. Okay, so now we've solved the examples for the 4 of them, and if time permits us, we'll solve more examples at the end of the video. If not, in subsequent videos, we'll solve more examples, so don't worry. Now we're going to move on to something called sinking fund. And this part is quite tricky. It's a bit some way, so I would like you guys to pay attention a lot. So when we talk about sinking fund, it's like an account that is set so that in case you want to get money at a particular period, at the end of a particular period, you'll be able to get. So you save, let's say, yearly. So assuming maybe right now I'm using a laptop. Yes, maybe I'm using a laptop, but then my laptop, it will get spoiled in 4 years' time. When I was going to buy the laptop, they told me that this laptop is going to get spoiled in 4 years' time. And the cost of a new laptop is 10,000 cedis. But I know that I can't get 10,000 cedis easily on the spot. So what I can do is that I can create a sinking fund. What this sinking fund does is that, let's say you'll be paying every year. So let's say maybe rather than paying the 10,000 CD on the spot, you'll be paying an amount every year. And the point of it is that by the time you pay the 4 years, you finish paying the 4 years, you'll be able to get the amounts that you need. I'm going to take it again. Let's assume by 4 years' time or 5 years' time, you need 10,000 cedis or you need an amount of money. But you know that time you can't get like the full amount. So you want to start saving now. You want to create an account so that by the time the 4 years has ended, you'll be able to get the amount you need. So what the sinking fund does is that anytime you put in an amount yearly, so if I'm saving for 4 years, if at the end of the 4 years, I need, let's say, 10,000 cedis. Yes, every year I deposit, I get an interest on it. Do you get it? So at the end of the day, I would end up paying lesser because I'm getting an interest. It's like I'm loaning someone. The person said maybe every year I should give me the person money. After the 4 years, the person will give me back my money, but with interest. So that's basically what a sinking fund does. So it's just like an account where you pay every year, and every year they'll be adding interest. So every year the interest keeps increasing. So your money keeps increasing, that's all. So now I want us to take a question on it. For this one, it's better we take a question on it so you guys understand the whole concept about it. So yes, this was a question actually given to us in class. So I'd like us to solve this particular one. So the question is, Admin Group 5 Limited has bought an asset with a lifespan of 4 years. At the end of the 4th year, replacement of the asset will cost 12,000 cedis. In this direction, the company has decided to provide a future commitment by a sinking fund account info with equal annual investment will be made at the end of each year. Interest rate at the investment is 12% per annum. You are required to A. Calculate the annual installment. B. Draw up the sinking fund schedule to show growth fund. So this is actually not difficult. So I want us to take it step by step. So let me explain the question. So the question is saying, let's say there is a company that has bought an asset. So an asset can be anything. It can be a machine, let's say a machine, but that machine has a lifespan of 4 years. So by 4 years' time, the machine would have damaged. That is what the question is trying to say. And the question is saying that the replacements, so if you want to get a new machine, let's assume maybe a new laptop, you need to pay 12,000 cedis for the new laptop. That is what it's saying. So, and the company doesn't want to wait till that time before they get the 12,000 cedis. They want to start saving now. So by the time the machine would have spoiled, they'll have enough money to get a new one. That's the 12,000 cedis. So it's saying in this direction, they created a sinking fund account where equal annual investments will be made at the end of each year. So they are saying they created an account, so at the end of each year for 4 years, they'll be paying an amount. So the aim is that by the end of the 4 years, they would have made the 12,000 cedis. Do you get it? So that's the aim of it. So what sinking fund helps you to, you get to know how much you are supposed to invest, because they are giving you interest now. So it's going to be less than if you're actually saving for it. And a normal circumstance, if I need, let's say, 24,000 in 2 years, it means a year I'm supposed to save 12,000. So this year 12,000, next year 24,000. But sinking fund, they are going to get an interest. So maybe rather than saving 12,000, it's going to be about maybe 11,000 or 10,500 because there's an interest. So sinking fund is going to let you know how much you need to pay to get the amount of money. That's basically it. So that's basically it. And the question said at an investment at a rate of 12% per annum. So 12% per 4 years. The rate is 12%. So now let's solve the question. So A says calculate the annual installment. The annual installment. So the annual installment means how much does admin group 5 need to pay at the end of each year, so that by the time the 4th year or the last year is done, they would have made the 12,000 cedis. You get it? So, and a normal circumstance, you might think that, oh, since it's 12,000 cedis, you just divide it, but it's not like that. This time they're giving you an interest, so it's going to be less. You get it? So the first one is say calculate the annual installment, how much you are supposed to save every year. That's it. So now, how do we solve that? Okay, so now among these 4 formulas, which formula do you think we'll use to get the annual installment? Yeah, the annual installment is the amount you're supposed to pay every year. If someone says you're paying installment, it means you're supposed to pay every year. So which formula do you think you use to find the annual installment? So it will be the second formula. Why the second formula? From the beginning, I made mention that this formula, the ordinary annuity, is when you are paying in installments or you are paying in bits. And then the future value of the ordinary annuity has been given to you already. That's the 12,000. So the 12,000 is how much you get at the end of the 4 years. And I told you how much, anytime it's how much you will get. Once it's future, then it is FVOA, the future value ordinary annuity. So they've already given that one to you. Do you get it? So because it is, you're paying in installments and they've also given you the future value, you use this one. So using this one, you are going to find for P, R, and N so that you can substitute in the equation. But the thing is that what we are actually looking for is P. Remember from the beginning, we said that P is the amount of money you are going to be paying regularly. And that's the installment. And the question is asking for how much you are going to pay annually or you are going to be paying for installments. And P is always the amount of money you are going to be paying for installment. So please keep it in your head. The P here you can see in the future value ordinary annuity is the amount of money you are going to be paying regularly or in the installments. And R is the rate, N is the time, the years. So now let's go. So the F vein, which is the future value, is already in the question. They said you will need 12,000 Ghana cedis. So indirectly, this is 12,000 Ghana cedis. The future value ordinary annuity is 12,000 Ghana cedis. The question said you would need 12,000 Ghana cedis. That is this. This is how much you will need, or yes, how much you are getting at the end of the 4 years. So if you invest whatever, how much you are getting, or how much you want, or how much you need is the FVOA. So that is 12,000 Ghana cedis. And FVOA is equal to this. So this is equal to this. And like I said, we are looking for the P. How much you're going to be paying for the annual installments. And P is, we don't know what it is. You are going to put the P there like that. Now, then the times. Then we have a fraction. Then the fraction, the numerator has into brackets 1 plus, that one is constant. Then the R is the rate, and the rate in the question is 12, if I'm not mistaken. Yes, the rate in the question is 12%. And then I always say, anytime they give you the rate, you are supposed to divide it by 100. So 12 over 100 will give you 0.12. So the rate is 1 plus the rate, which is 1 plus 0.12. Then exponent n. Then n is the number of years, and the number of years is 4 years because they want to get it at the end of the 4th year. So exponent 4 over the rate. The rate is 0.12. Then the numerator here is minus 1. So I almost forgot to bring it actually. So minus 1. So what you see here is just what is here. We've just replaced the value. The future value ordinary annuity is the 12,000. How much we want to get, that's the 12,000 here. The P is here, we didn't change it. The R here is the 12%, 0.1 to 12 over 100. And the N is the number of years, which is 4. So now we have to do a simple change of subject to make P stand alone. So P is the amount of money we are supposed to be paying yearly. So how do we make P stand alone? We just, simplify the equation. So we have 12,000 at the left side. And we have P times all of this. You don't need to do it step by step. You could just use a calculator. So when you use a calculator, guys, please do it on your calculator and let me know what you guys get. So 1 plus 0.12 exponent 4 minus 1 all over 0.12. So when I did it on the calculator, I had 4.779328, which is the same as 4.78. So times 4.78. So all this is giving 4.78. So now we have P times 4.78 at the right hand side. But P is still not standing alone. So what do? We simplify the right side of the equation. Then we have P times 4.78. So we get 4.78P. Then P is still not standing alone. There is something attached to it. So we still need to let P stand alone. And what do? We divide both sides by 4.78. 4.78, 4.78. We are dividing both sides by 4.78 because that's what's attached to the variable. So by 4.78. And here we'll cancel each other. So P is now standing alone. So now what do we get for 12,000 over 4.78? So I had 2,510. 2,510. So yes, we get 2,510. Sorry, what it means is that every year they are supposed to save 2,510 at the end of the year before they'll be able to get the 12,000 they want. That's basically it. So they're supposed to save 2,510. So that is for the A part. Now let's go to the B part. What does the B say? The B says that we should draw the sinking fund. So this is where the sinking fund comes inside. So guys, make sure you pay attention to this side. So it's 2,510. I'm going to write it somewhere here so that we don't forget. So remember that this is what they are going to be paying every year. Now, this is the sinking fund. We've actually not done it yet. So the sinking fund, it says you should draw a sinking fund schedule or a table. So let's look at how we go about the sinking fund schedule or the sinking fund table. So these are the 5 things you need. The first one is the year. So the year, it depends on how many years they give. This one, they said at the end of the 4th year. So we have 4 years, the 1st year, 2nd year, 3rd year, and the 4th year. And the next one is the opening balance. The opening balance is the amount of money that is in the account at the time you are depositing. So at the time you are depositing the first one, there is no money in it. When you are going to deposit the first time, there's no money in it. So the opening balance is 0. So always, when you have a question like this, the opening balance is always 0. Now, For the deposit is the money you are paying every year, your installment. And remember, we solved for it. You are paying every year. You are going to pay 2,510. So meaning first year 2,510, second year 2,510, third year 2,510, then fourth year 2,510. This one is always the same. It doesn't increase nor decrease. It's always the same. So yes, that's for the deposit. How much you are paying every year. And the interest end is how much the interest you are getting from each of them. And remember, this one we are dealing with compound interest, meaning that you don't calculate for the first year, you don't calculate for this, second year calculate for this, third year calculate for this, fourth year no, you don't do it like that. When it comes to compound interest, when you get the interest for the first year, they add it to the second one. Then you add the interest for all of them. That's how you get your interest. When we solve the question, you understand. Then the total balance is how much you're getting at the end of the year. So for the first one, if you want to get the total balance for each of the years, you add the opening balance plus the deposit plus the interest end. That's how you get your total balance. Do you get it? So the opening balance is 0 because you didn't meet any money as of the time you were opening the account. No one gives you free money. You deposited 2,510 that year. Let's assume it's this year. Let's say October 20. I deposited 2,510. They won't give me interest that year. If I invest 2,510 in any bank, let's say October 2024, the next time they'll give me the interest, or the first time they'll give me the interest, is the next year. Because this one is annually, every year. So they'll give me the interest in the second year, next year, not this year. So for that first year, the interest end is 0. I'll earn the interest for this one in the next year after 12 months. Then they'll give me the interest. So the total balance will be this plus this plus this. The opening balance plus the deposit plus the interest end. And I'll get 2,510. Now the second year, the opening balance, remember that the first year we've deposited 2,510, the one that they didn't give us the interest, no. So now we are going to meet the 2,510. That's the money we meet when we are making the second one. But you are going to earn interest on it. The interest is the one we earn for the first year. The first year, remember they didn't give us our interest. They'll give it to us in the second year. If I make an investment right now, they'll give me the interest the next year. So the deposit I made here, the interest is what I'm about to calculate. So this is the first interest I've calculated. So I'll calculate it on the first deposit. So how do we calculate that? They said an interest rate of 12% per annum. So 12% per the deposit, which is 2,510, because they're giving you a 12% interest. So 12%, 12 over. So you do 12 over 100 times 2,510. And you are getting 301. When you do that, that's what you are going to get, 301. So let me know if you guys got the same answer. It's 301.2, but you can just do it 301 to calculate it easier. So this 301 is the interest earned for the first year. The first year that they didn't give us the interest though. And now the total balance is going to be the money we deposited that year plus the money we deposited the first year plus the interest they gave us for that money the first year. So the money we are depositing the second year, they've not given us the interest yet. So that one here is there. But remember they gave us the interest for that the first year. So you're going to add the interest and that money too. So when you're going to add the opening balance, the deposits and the interest end. Which is when you add all of them, 2,510, 2,510 plus 301. You should get 5321. So this is the total balance for the second year. And remember, the total balance for the previous year is the opening balance for the subsequent year. So here, the total balance, you realize that is the opening balance for here. So the total balance for second year is the opening balance for the third year because that is the money you meet. This is when you have not made your deposit yet. This is the money you have. They are not adding anything yet. So the deposit, you are still maintaining the 2,500. We are paying it every year. But they are going to give us interest not on this. But remember, they are going to give us interest on what we made at that time or the money we have that time, which is the opening balance. They are going to give us the interest on 5,321. So now it is 12 over 100, which is 12% of 5,321, which is 638.52. So if we want to get the total balance for that year, we just add this, this, and this, which is the opening balance plus the deposits plus the interest in. And when you add that on the calculator, you're supposed to get something like 8,469. Yours might be slightly different depending on the approximations. So 0.5, let's do 0.5. So it means at the end of the third year, this is what you have. And like I said, the total balance for the previous year is the opening balance for the subsequent year. So for year 4, you have 8,469.5. This is the last year. This is the last year. And the last year, we've also deposited the 2,510. So they are going to calculate the interest on the money you have now. On the money you have now. So now it is so every year you are going to be calculating the interest on the opening balance, which is 12% times 8,469. And that should give you 1,016. So it means the interest you earn at the end of the 4 years is 1,016. So now to get the total balance for everything from year 1 to year 4, you add this, this, and this. And when you add it, you are supposed to get 12,000. Or if not 12,000, something very close to 12,000, maybe 11,900 and something. Yes, very close to 12,000. So let's see if our answer is correct. If you don't get anything close to 12,000, it means our answer is wrong. We'll have to do it again. Yeah, so we got 11,995, meaning our answer is correct. So this is the money you are going to earn at the end of the 4 years. Remember, we wanted 12,000. We got very close to 12,000. So that's how we solve it. So if you get any question like that, just remember you have to add the opening balance, the deposits, and the interest end. And the opening balance is the money you go and meet. So the first year, we went to meet zero because we are now creating the account. We deposited 2,510. The interest, they didn't give us interest, but they gave it to us in the next year. So that's basically how you calculate it. So guys, unfortunately, time is fast spent, so we couldn't solve a lot of questions, but there are so many questions we could solve, and I'll be solving a lot of questions subsequently. And if you don't understand anything, just let me know. I might even do a video, maybe slowing down or breaking it down, solving more questions. So don't hesitate at all. And yes, I'll see you in the next video.